Chemsters, this is Mrs. Vanderlei bringing you the 8.4 blank wall edition. This carries on from what we just did in section 8.3. What is new in this section is the idea of valence electrons. Those are your outermost electrons. Why do we care about those? Because those are your bonding electrons. We're getting closer and closer to establish, where are these electrons and how many do I have to play with. Let's go that way. So problem number 2 says go back to problem number 1 and determine the valence number of electrons in the above elements. Then fill in the remaining below. Okay, so let's go back over here. We want the outermost electrons. So really the question is, can you count up to 7? Okay, let's see how you do. I'll use green. So what's your biggest number? 1, 2, or 2? Tough question. What do you get? I got 2. So how many total electrons are in the second shell? It looks like 2 plus 4, and that's 6. So there's 6 valence electrons. What about magnesium? Okay, what's your biggest number? 1, 2, 2, or 3? Well, I think it's 3. So how many total electrons does magnesium have? How many valence electrons, I should say? And how many total are in the third shell? It is 2. Okay, what about aluminum? What's your biggest number? 1, 2, 2, 3, or 3? Well, I think it's 3. So over here, how many total electrons do you have? It looks like you have 3. How about silicon? What's your biggest number? 1, 2, 2, 3, or 3? I think it is 3. So how many total valence electrons do you have? 4. How about phosphorus? 1, 2, 2, 3, or 3? I believe it's 3. So how many total electrons are in the third shell? You get 5. Chlorine, it's not 6. We jumped one, didn't we? 1, 2, 2, 3, or 3. I think our total value is 3. So 2 plus 5 is 7. Now, careful with scandium. What's your biggest number? 1, 2, 2, 3, 3, 4, 3. Which is your biggest number? It's 4. These are not valence, okay? So you have 2 valence electrons. What about bromine? 1, 2, 2, 3, 3, 4, 3, 4. What's your biggest number? 4. So I have these and these for a total of 7. Okay, that's not too hard, is it? I don't think so. So what did we have here? This was oxygen. I think we had was 6. 1, 2, 3, 4, 5. We didn't do sulfur, but let's do it anyway. 6, 7, 8. We did scandium, had 2. Germanium has 4. I don't know where germanium came from. And bromine had 7. Okay, so I asked, is there a trend? Well, look at this. Look at your periodic table. What's our trend? Sodium had 1. I bet they all have 1 in group 1. Group 2 all has 2. Group 13, 14, 15, 16, 17, 18. Helium, though, has 2. Because remember how helium kind of belonged next to hydrogen over here? How many did our D block have? 2. Why only 2? Because this number is always, the S is always bigger than your D. Right? 4S, 3D, 5S, 4D. And if you're to even go down here, these also have 2, because if you look over here, it's 6S2, 4F14, 5D. 6 is the biggest number, so it only has 2. So let's see here. So what's our trend? It goes 1, 2, 2, 2, 2, 2, 2, 2, 2, 2. Pick up back at boron, 3, 4, 5, 6, 7, 8. Helium has 2. That's true for anything. So let's just pick some out real fast. How many does barium have? 2. How about, oh, here's one maybe, I don't know if you've ever heard of. How about borium? How many does borium have? 2. How about flavorium? How many does flavorium have? Well, it's in group 14. It has 4. Okay, how about, I don't know, tellurium? It has 6. Okay, so in any of these, so uranium, plutonium, all have 2. Here's uranium, here's plutonium. They'll have 2. So look how easy that is. That's pretty easy, isn't it? Let's go to the next page. So it says, note the number of columns in a block corresponds to the maximum number of electrons that can occupy a particular sublevel of that block. Therefore, S has 2 columns. It can max out at 2 electrons. How many columns are on the periodic table in the P block? It is 6, so it maxes out on 6 electrons. D has 10. And F has 14, okay? The group number tells you the valence electrons. So if it is in the old way, when you're talking about 1A, 2A, 3A, so if you look back at that periodic table that I just showed you, you'll see there's maybe a different way of doing it. Let me erase some of this so you can see it. On the top here, do you see where it says 1A, 2A, 3A, 4A? Do you see that? That's the old way of naming the groups, and that tells you how many valence it has, all right, except for poor helium over here. And then the B's will still have your 2 valence. Now, what about the new way, when we just go 1, 2, 3, 4, 5, 6, 7, all the way up to 18? Just know 1, 2 has 2, 3 through 12 has 2, and once you pick up at 13, then just subtract 10 as 3, 4, 5, 6, 7, 8, okay? All right, so that's kind of easy, I hope. So it says write the electron configuration for an element in its position on the periodic table. So write the noble gas configuration. So here's chlorine, go backwards, here's neon. So then notice what it says right here, that's your 3s2, 3p5. So I don't even have to even know how many electrons it has. I don't care that it has 17 electrons. I'm just looking at the periodic table and knowing I have these guys here and then 5 over here. So why don't you go ahead and do the next 3 and see how, you pause this, do the next 3 and see how you do. All right, so here we go. I have the ones filled out here. Let me kind of erase this real fast. There we go. So did I do chlorine with you? I don't remember. But anyway, it's neon. Yes, I did. 3s2, 3p5. Selenium. I found selenium. I was trying to do that. It is right here. Here's selenium. So it is argon, which is this noble gas. All right, there's argon right next to chlorine. That's an AR there. And so 4s2, 3d10, 4p4. Bismuth is down here. Here's bismuth about right there. So it was xenon, 6s2, 4f, don't forget your f's, 4f14, 5d10, and 6p3. And then the next one is iodine, which would be right here. Here's iodine. And so that would be 5s2, 4d10, 5p7. All right, so what about the transition and the inner transition? I call those the F block elements. I don't call them the inner transition. The principal energy level of the d orbitals that fill across each row in the transition series is equal to that row minus 1. That's why it's 4s2, 3d. And for the F block, it's the principal energy level minus 2. So here I have vanadium and tungsten, uranium and plutonium. Why don't, let's do vanadium. I think we've already done vanadium. Notice that the D is 4s2, 3d3. Notice it's a 3. Go ahead and do tungsten. See how you do there. Hopefully you pause this, and this is what I got for tungsten. Notice that my F came first. I had my 6s, 4f, 3d. I had to subtract 2 to get to my F. Uranium and plutonium are both in the F subshell, so why don't you go ahead and do those guys real quick. Okay, after you paused it, hopefully you're coming back. So we have radon, 7s2, 5f4, and then radon, 7s2, 5f6. So obviously neptunium is in between those two. That concludes section 8.4. Hopefully it wasn't too bad for you, and don't wait to be great.